Okay, here we're going to look at a nice integral involving the logarithm and the tangent function. And finding the value of this integral is not super hard, and that's actually not really the point of this video, finding the value of this integral. The point of this video is to present you with some philosophical idea I have, and that is that your solutions to math homeworks should maybe be written in a nice and clever and succinct way. So, whereas a standard solution of this would involve these kind of behind the scenes steps of using this tangent identity, tangent of pi over 2 minus x equals 1 over tangent of x, motivating a substitution from this identity, setting up an equation for the integral and solving, I think a much more aesthetic solution just starts at our goal and ends at the value of our goal without setting up an equation for an integral or anything like that. So in other words, the solution that I'm going to give right here is not a first draft. This would be like a final draft for writing down a solution for this integral. So the first thing that I'm going to do is write this as 1/2 times the integral plus itself. So obviously the integral plus itself is twice the integral, but if we multiply that by 1/2, we just get the integral that we're looking for. So I haven't done anything magical here. So I've got the integral from 0 to pi halves of 1 over the natural log of tangent of x plus 1 over 1 minus tangent of x. And all of this is dx, but now I'm going to add that integral exactly to itself. So again, an integral from 0 to pi over 2 of 1 over natural log of tangent of x plus 1 over 1 minus tangent of x, and then dx. Okay, and then we've got to close off this big bracket. Okay, so next I'll just bring this first integral down as is, and then I'm going to make a change of variables in the second integral based off of this behind the scenes that I told you about. This identity tangent of pi over 2 minus x equals 1 over tangent of x. So let's see what that gives us. So like I said, I'll have 1/2 on the outside of everything. I'll bring this integral down. So this is going to be the integral from 0 to pi halves of 1 over natural log of tangent of x plus 1 over 1 minus tangent of x. And all of that is dx. Good. Now doing this change of variables, I'm going to have the integral. I'll do the bounds a bit later, but I have 1 over natural log of tangent of pi over 2 minus x. So that's what happens there if I replace x with pi over 2 minus x. And then I have plus 1 over 1 minus tangent of pi over 2 minus x, like that. And then finally, I have d pi over 2 minus x. Great, and then we need to close off our bracket because that is all being multiplied by 1/2 here. Then let's go ahead and see what our bounds of integration are. So notice these are x bounds of integration. When x is equal to 0, pi over 2 minus x is equal to pi over 2, like that. And then when x is equal to pi over 2 minus x is equal to 0. So that gives us the bounds of integration flipped like this. Okay, so next I'm just going to keep bringing this first integral down. So I've got that integral from 0 to pi halves of 1 over natural log of tangent of x plus 1 over 1 minus tangent of x dx. Good. Now the next thing that I'm going to do is use the fact that d pi over 2 minus x will just be minus dx. That's the differential of that very, very simple linear function. But that minus sign can be used to flip the order of integration here. So that's going to give us now the integral from 0 to pi over 2 at the top of 1 over natural log of 1 over tangent of x. Again, using this identity that was behind the scenes. So I've replaced tangent of pi over 2 minus x with 1 over tangent of x. And then I have this is plus 1 over 1 minus 1 over tangent of x. Again, using that identity one more time. So now these integrals are situated in a way that I can combine them together into one integral. And that's exactly what I'm going to do. So that's going to give me 1/2. And now I have the integral of 1 over the natural log of tangent of x. And then notice that this 1 over the natural log of 1 over tangent of x can be replaced with minus 1 over the natural log of tangent of x. And that's because the natural log rule, natural log of 1 over something is minus the natural log of that something. So that's what we get for that part. And then here we can write this as 1 over 1 minus tangent of x. I just brought that down. And then we can multiply the numerator and the denominator of this maybe by minus tangent. And that's going to give us minus the tangent of x over 1 minus the tangent of x. Great, and now we can close all of this off with a dx. And again, this is my integral from 0 to pi over 2. Okay, so now let's see what we've got. This 1 over natural log of tangent will cancel with this 1 over natural log of tangent. And then these two things add up to 1. So let's just write that out. So we've got 1/2, the integral from 0 to pi over 2. That cancels. I'll just let that cancel down to 0. And then we've got 1 minus tangent x over 1 minus tangent x dx, but that's just going to be 1/2 the integral from 0 to pi over 2 of dx, the integral of the function 1 dx. But now notice that that's just going to be 1/2 times pi over 2, which gives us pi over 4. And I think that's like a nice aesthetic way to start at this integral and end at the value without mucking around with setting up an equation for the variable. And obviously this is something that you would only do after you had done all of that stuff in the background. Okay, maybe I'll go ahead and clean this up and give you guys some examples of other integrals that maybe you could rewrite standard solutions in this new strategy. So we just showed that our goal integral had a value of pi over 4, and we did it via a nice continuous equation. And so here's my task for you, especially if you're in some sort of calculus 2 type class, is to do any of these integrals that you often see in calculus 2 where you set up an equation for the value of the integral. Well, to rewrite a solution where you just start with the integral on one side and then the value of the integral on the other side without mucking around by setting up an equation for the value of the integral. So I think this can probably be done well with sine squared and also maybe with e to the x times sine x. You generally do both of those with integration by parts. I bet you could set up one long string of an equation that starts with this and then ends with the value of this. And you can probably do the same thing with this integral as well. And there's going to be a number of other integrals that this would work for as well. So maybe post in the comment your favorite integral that could have its standard solution rewritten in this nice aesthetic single equation method. And that's a good place to stop.